Yeah, you can.
Okay. Well, for the stream. Hello, everybody. Welcome to Upstate Carolina Linux Users Group and Columbia Linux Users Group in Columbia, South Carolina, and Greenville, South Carolina, in non-respectively. Yes, the South Carolina Linux Users Groups. Appreciate y'all coming tonight. And tonight we got Ben Francis down in Columbia. Hello, Ben. And,
hey, y'all.
And he's going to tell us, or he's going to get us started about with Linux from scratch. This was an idea that had come to me after Hack Greenville Nights. A person came up to me and said, "Hey, wouldn't it be great if we all kind of as a group went through it?" And I thought it was a great idea. And we didn't really have a topic for tonight yet. But Ben, having gone through it twice, said that he could get us started. So I think it'd be great. And maybe we could decide on if someone wants to pick up the next chapter next month or something like that. Or maybe Ben will continue. We're not sure. Whatever. I'll let you take it away, Ben. Thanks so much for doing this tonight.
Okay. Yeah. Thanks, Jace. All right. So I'm having all kinds of technical difficulties. I was going to present my voice and image on the laptop and then do this project on the gaming rig. And then I just went over and tried to install another drive on the gaming rig and moved it with my hand, and the gaming rig, I accidentally hit the reset button and shut the gaming rig off. Anybody ever done that with a server? Not me. All right. So anyway, this is the Linux from Scratch project at linuxfromscratch.org, founded by Gerard Beekmans 27 years ago. How about that? Wow. That's something. And the user interface has not changed since then. Not when I tried it, 15 years ago, and it hasn't changed. So sometimes we like things that don't change. But the Linux from Scratch book is kind of daunting because you have to go through this table of contents. You got to go through this whole preface and read everything, and then you got to go through the introduction, and then you got to prepare for the build. You got to prepare your host system, your gaming computer, whatever that you're gonna, or laptop, wherever you're gonna do this project. You got to download packages. You might need to do some patches. You got to do some final preparations. You got to add the LFS user. You got to do a whole bunch of stuff. And then once you do that, then you can start building the Linux from scratch, cross tool chain, and do tools. And then you got to add all these. You got to, if you're going to do a compiling across tool chain, you got to do all this. And I think we do have to do that because I'm on a Mac, Silicon, 64-bit, and I need to be able to compile for the Intel 64 chips. And you got a whole bunch of tools, temporary tools that you're going to load, and then you got to enter your chroot and do all this stuff, and it's starting to get complicated. And then you can start building, and and each one of these is a page. Like, here's an introduction, and every page is like this, just a whole blob of text that is just almost makes you want to put a gun to your head and pull the trigger, but it's kind of tough. Okay. And so just to give you an idea of the amount of time it took me the first time, I was on a 200 megahertz processor, and it took me, I was doing it off and on between work and this, and it took me 2 months to get everything going, partly because of all the reading, well, mostly because of all the reading, but the compile time was not insignificant. I mean, when you run make on that compiler, it just goes and goes, and it went for it had to go for 2 or 3 hours. Anyway, so anyway, and then there's more. There's system config, making your system bootable, and then at the end you can get counted and um, make your yeah. It's just what does it say here? Yeah, you just click on a link and say, "Hey, I did it," and the counter goes up. And no, it's just in PHP, so that'll tell you how old it is. Um, and then that's it. But that's just the base system. If okay, I was expecting. Oh, okay.
I don't know if
See,
it's two questions, but as someone who's never done the Linux from scratch before,
yep.
this how close is this to like a build that we know of, like a Debian based build or like Arch or something like that? Or is this just like the bare bones, like the kernel and some core, extensions?
This is just the core. So I'm going to go to the real. This is what you see when you go to linuxfromscratch.org. And this is all kind of confusing because you're like, well, what is all this? Well, let me explain it. So this LFS is Linux from scratch. That's the bare bones. That's just to get the kernel running without any real applications that you would use on your regular computer, like a net browser and I don't know, mail program and all that stuff that you would normally use. Yeah, that's not in here, and it took me 2 months to do that. Now I did it a second time, and I got it done in a weekend. And the notes from Linux from scratch say that it should take about 8 hours. So, so I'm guessing if we decide to keep doing this, we could get this done in four sessions, I think. But at the end of that, we might not have a user group.
Well,
so anyway,
I'll still be here.
yeah, right. And then there's all these other projects that are here. They're also doubled up here up top. So what is, you got BLFS, beyond Linux from scratch. That's where you actually extend or install applications that you want to use. There's automated Linux from scratch that uses a program called JHAFS to automate a lot of the whole process of copying and pasting all these commands. And then you have multi-live Linux from scratch, which is a variant of LFS, which sets up the LFS system that is able to build and execute 32-bit binaries. I know y'all can read, but some people on YouTube will expect to have sound, and so.
Hey Ben, we've got a question in here.
Yeah.
So when we're talking like Linux from scratch, are we talking like I already have an operating system installed and I'm just compiling the kernel and all of its other all the other parts of the Linux system, or are we talking like I'm literally running building tools to be able to get this all up and running from the BIOS?
Well, before I had my mishap, I had all this in a live OS. I had Pop OS booted from a thumb drive on my gaming rig, and I was going to run the whole project that way. And so run off the thumb drive, go to this website, and then just do the book. And the way you do the book is You click on Linux from scratch right here, and then right on the side here you have this read online, which is the way I do it. So yeah, that's you got to have kind of an Ubuntu or some other distribution that you're booting from the side, so you can install your tools and stuff on another partition or disk drive, and then once all the tools are there, then you can boot into that environment and then create a build directory and then start putting the system together. But this is really like building a car when you've got you've got a frame, you got some wheels, you got an engine, you got a transmission, and nothing's assembled. So does that answer your question?
Yes, sir.
Okay. Yep. So yeah, it's kind of a mystery how to even get started with this thing, because you're looking at this, like, okay, what do I click? Well, this is what you click. It's got a lot of metadata about what these other distributions that you can build on top of LFS are. Supplemental Linux from scratch, gaming Linux from scratch. I haven't done any of those, and it's got hints and patches and an LFS editor's guide. But yeah, why you would want to do this? Because you want to learn, the nuts and bolts of how Linux goes together, and then the whole the deployment process of being able to file from source. So what is
Now, are those others? Assume you've already gone through the baseline Linux from scratch, or do they start from the beginning?
They start at the beginning. Well, yeah, they start at the beginning. So you got to have some kind of operating. I'm pretty sure you need a Linux operating system, because.
No, I guess what I'm asking is if I want to go through multi-lib Linux from scratch, do I have to have finished Linux from scratch, pick up where MLFS starts?
Yep. Yes. Okay. Yeah, all those other distributions, the BLFS, ALFS, GLFS, SLFS, they all stand on top of LFS, which is the kernel. Yeah.
Okay.
That's it. So we click here, we read online. There we go. And then, and we're still not there, because we got to read all this stuff. And what is all this? Oh boy. Oh my goodness. Which one do I click? Well, you click the first one. You want to click stable. Well, yeah, you do want to click the first one, because this has the errata for this, and this release came out I believe in October last year, for a 12.4 version of the book, of the LFS book, and it says packages. Total size of all the packages should be 583 megabytes. And the Free Software Foundation wanted to change all references of ftp.gnu.org, which is, well, thought they were talking about security, but they just changed it to ftpmirror.gnu.org. Okay, so that's not too bad on that part. And then the security advisories page says, oh yeah, here's all the stuff that went wrong with this distribution, which is not too bad. You got a couple of bugs, OpenSSL. That one's big, severity high. So that one you definitely got to make sure you patch.
Oh, well, that was just this week.
Yes. Well, February 1st.
Right, last week.
Yep. So I didn't know about it, so I was like, "Oh, that's news." I'm sure the whole world has already updated their OpenSSL packages by now. I'm kidding.
We just did it.
99.999% of people have not updated that,
Yeah.
unless you're working with Ubuntu and you know they're automatically putting out patches and they give you a little flash notification that says, "Hey, you need to update because your system's insecure." So, yep, that was a big one. And GLIG, this is a very important library, and its severity is high. Also, this is only for developers, but we do need it in our tool chain to be able to build the kernel. So that's pretty important. All right. So then we go back and back. So we did the errata. We looked at the security advisories. Now we can start stable LFS. Woo! All right. And then it's just a wall of text on every page. I'm sorry. I'm not going to read all this. It's just a memo from Gerard Beekman saying he wanted to customize the system and he wanted a system that was more customized to the way he works. And so that's what he did, and the result was LFS. So next page, who's the audience for? It's for developers. It tells you that LFS can allow you to create very compact Linux systems. If you just want to compile for one CPU and that's it, because you know that your compiled code is only going to run on this one computer, then you don't need the 30 other processors that Linux supports. And I'm just guessing there, but it seems like that's what it was in the in the menu config. So, yep, and security is another reason why you would want to do it. I mean, actually, there's no difference between compiling Ubuntu from source and just getting it from the web and downloading it and using it. It's going to be the same security. But he's talking about removing the huge footprint that Linux is, and he's saying it empowers you to audit everything and just install the packages that you want. Way back when, probably 8 years ago, I counted the packages in Red Hat, and there were over 420 packages that Red Hat included in the distribution, and that's a huge footprint, and that's how you can get hacked. Because how are you possibly gonna know that all 420 packages are patched and up to date all at the same time? I mean, even Red Hat has a hard time keeping all that stuff secure. So that's another reason why you want to learn it or go through LFS and learn the nuts and bolts of how to put this together. LFS target architectures are 32-bit and 64-bit. He's saying the difference between the 64-bit and the 32-bit system is minimal. Using fours, the following statistics were measured. 32-bit is build size is 3.6 and 4.4, and they both 64-bit was faster by about 6 minutes. So if you're, I mean, people still work on 32-bit embedded processors because they don't need 64 bits. And there's more. I mean, the more bits you add, like the famous story of the shuttle, or I mean, the original Apollo space program didn't even have a let's see, expecting that they would have had a 32-bit computer, but they didn't. They had 4 bits less, and I asked, well, how come you only had a? And that doesn't sound right. Hey, I don't think they could have had 32 bits back then. So I was expecting 16-bit computer, um, but but theirs was 4 bits less, so it was a 12-bit computer. And I was like, why didn't you go with 16? Because, and he said, because every single bit you added additional complexity and more things that can go wrong.
Yeah.
Yeah. So I don't know why 12 seems a little bit. That's a little bit. No, that's what it had to be. I mean, I just remember it was like 2 or 4 bits less than what I expected for a 1970 computer. Anyway, so that's a little bit about target architectures, and we go to prerequisites, um, and they talk about software building, how to, and they say if you haven't gone through this, this is going to be a rough experience. So, so you go to, I mean, more stuff that you have to read. And I never read this. I don't think no, but it's helpful because I knew a little bit about Make, and first time I did it, and I was like, I know about prepackaged binaries, so I didn't do that. But if you don't know anything about how software building is going, then you really should do that. Or you can do the beginner's guide installing from source. Kind of interested here. Oh, another wall of text. All right, we don't need that. That's all you got me there. All custom standards. So Linux from scratch follows three standards. POSIX is the first one, and this was LFS was started in 1998, so this was 10 years before POSIX.1 was formalized. And I don't know much about POSIX. Maybe somebody else does. Anybody else? It's just a standard for how a computer should be set up.
How a Unix like.
A Unix. Yeah, Unix like computer. So it probably says you got to have a root partition and a home partition and a user partition and all that stuff.
Everything's a file.
Yeah,
that sort of
file. Yep. Yep. All the good Unix stuff. File system hierarchy standard has been around a long time. Now it's up to version 3. Open that in a new tab. Check it out. Another wall of text. All right. Wow. So, yeah, this the FHS just tells you what /bin is, and boot, and /dev, and /etc, and home. All the top. Well, every single library in the whole, or every single directory in the whole Linux system. So that's some fun reading to fall asleep to. And then you got the Linux standard base version 5. At some time in the Wild West of the early 90s, Linux was Slackware. It was what was the other distribution? Jays.
Yggdrasil.
Yggdrasil, yes, that's what I knew I wasn't going to remember that one. I knew I had to call you.
And what was the other one? Well, no, actually, Red Hat is 1 month older than Debian.
Yeah. So you had Debian, Red Hat, Yggdrasil, and Slackware, and or compiling the whole kernel from source, like we're doing here. And that was your options, and none of them played. None of them played the same way. So smart people got together and said, "Hey, to get Linux to grow bigger and better, we gotta have some standards here, and at least with the file system, file system and POSIX and all this other stuff." So that happened, and okay, I need that. Rationale for packages in the book. These are all packages. We're in the E's, G's. There's quite a few. So if we went all the way to the bottom, and 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 packages, 10 pages of packages. So, and there's about 7. So about 70 packages total. And they have an explanation for why each package is in there, which is nice to have, and know everything that your system can do. And if you don't have something that you need, then you need to go to Beyond Linux from scratch and install the package from there. Typography, structure. Yeah, we went through this. Go ahead and had the introduction, prepare for the build, building the tools, and then you just start building until part 4. Errata, got that. Constantly being updated. And that was, after reading all that, now you're into the introduction. All right. Anybody need a bio break? All right. All right. How to build an LFS system. All right. This was going to be a wall of text. All right. LFS system will be built by using an already installed Linux distribution. So yeah, right out of the box, you gotta have Linux to make Linux. You gotta have money to make money. So, man, this is old. Is Open Mandriva even still around?
Oh goodness.
I know. Well, Debian, Fedora, and OpenSUSE are still around, but yeah, Mandriva, I think I haven't heard of that one in a long time. This is existing Linux system, the host, this whatever laptop you're building on will be used as a starting point to provide necessary programs, including a compiler, a linker, and a shell to build the new system. Select the development option during the distribution installation to include these tools. Yeah, they're talking about if you're working off Ubuntu right now, like that, you do that. So
the latest release of Open Mandriva LX 6.0 was 9 months ago.
They're still kicking, I guess.
I guess so.
All right. All right. So chapter 2 shows how to create the new native Linux partition and file system, where the new LFS system will be compiled and installed. Chapter 3 explains how packages and patches must be downloaded to build an LFS system, how to store them on the new file system. Chapter 4 discusses the setup of an appropriate working environment. Please read chapter 4 carefully as I explain several important issues you should be aware of before you begin to work your way through chapter 5 and beyond. So yeah, one through four is all building, just getting ready to do everything. And then 5, you install the initial tool chain. 6 shows you how to cross compile, and 7 gets into the CH root environment, where we use the new tools to build all the rest of the tools needed to create the LFS system. And then chapter 8. What's new since the last? Oh, okay. All right. So you get a release notes here of what all the packages have been upgraded to. So that's kind of nice. And they have a nice change log. Resources, they give you FAQ, mailing lists, IRC, internet relay chat, mirror sites, and contact information. 5, 1.5, help.
Yeah.
Yeah, forget that. You know, it's there.
We're all here for each other.
Yeah, preparing the host system. Okay, now we made it to second part, preparing for the build. And this is all that preparation. All right, so preparing the host system. Introduction. So this chapter, the host tools needed for building LFS are checked, and if necessary, then a partition which will host the LFS system is prepared. We will create the partition itself, create a file system on it, and mount it. Host system requirements. Okay. So you got to have a Linux system with all these packages installed. And if you're using Ubuntu, the package that has all these things is called, well, it used to be called Build Essential. I think it's still called that. Anybody have a Ubuntu machine there? So you would do apt-get install build essential, and on top of a regular Ubuntu system, it would add all these tools, and then you would satisfy host system requirements plus all this stuff. Make right here is the program that actually builds software and can build a kernel. And they recommend having a machine that has at least 8 gigabytes of memory and 4 cores, four CPUs. All right. And this page is about tells us that we have to build LFS in stages. It's designed to be built in one session, one 8-hour session, if your butt can take it.
System will not shut down. Okay.
Yeah. The instructions assume that the system will not be shut down during the process. This does not mean that the system has to be built in one setting. The issue is that certain procedures must be repeated after a reboot when resuming LFS at different points. So, I guess just leave the computer running, come back the next day. Chapters 1 through 4 run commands on the host system. When restarting, be certain of one thing. You must have the LFS environment variable set for the root user. Very important. And then chapters 5 to 6, you're going to mount the LFS partition. These two chapters must be done as user LFS. So you got to issue the switch user LFS command before you perform any tasks in those chapters. If you don't do that, then you're going to screw up the host and potentially render it unusable. So that's fine. The procedures and general compilation instructions are critical. Let's take a look. What are we talking about here? Yeah, you got to run this command echo LFS, and two important items to emphasize: the build instructions assume that the host system requirements, including symbolic links, have been set properly. Bash is the shell in use. SH is a symbolic link to bash. User bin awk is a symbolic link to gawk, and user bin yak is a symbolic link to bison, or a small script that executes bison. And here's the synopsis of the build process. You put all the sources and patches in a directory that will be accessible from the ch root environment, such as mount LFS sources. You change to the sources directory, and then for each package, using the target program, you got to extract the package to be built. Ensure you are the LFS user. Here, when extracting the package, do not use any method except the tar command to extract the source code. Notably, the cp-r command to copy the source code tree somewhere else can destroy timestamps in the source tree and cause the build to fail.
Oh, interesting.
Yeah, I'm reading all this for a reason, because to refresh my memory and expose you to it. You got to change to the directory created when the package was extracted. You follow the instructions for building the package. You change back to the sources directory when the build is complete, and then you delete the extracted source directory unless instructed otherwise. All right, so that's, we don't need that anymore. And then in chapters 7 to 10, the mount LFS partition must be mounted. A few operations from preparing virtual kernel file systems to entering the chroot environment must be done as a root user with the LFS environment variable set for the root user. When entering chroot, the LFS environment variable must be set for root. The LFS variable is not used after the chroot environment has been entered. And the virtual file system must be mounted. Hide. What happened there? You hid the whole window? I'm lost. It goes in. Yeah. Here. Okay. Enough said about that. All right. Here's where I ran into trouble trying to create partitions on a Mac. Like most other operating systems, the LFS is usually installed on a dedicated partition. The recommended approach to building an LFS system is to use an available empty partition, or if you have enough ARM partition space, to create one. A minimal system requires a partition of around 10 gigabytes. This is enough to store all the source tarballs and compile the packages. However, if the LFS system is intended to be the primary Linux system, additional software will probably be installed, which will require additional space. A 30 gig partition is a reasonable size to provide for growth. The LFS system itself will not take up this much room. A large portion of this requirement is to provide sufficient free temporary storage, as well as for adding additional capabilities after LFS is complete. Additionally, compiling packages can require a lot of disk space, which will be reclaimed after the package is installed. Because there is not always enough random access memory available for compilation processes, it's a good idea to use a small disk-based partition as swap space. And we're not going to do this because it used to be that swap space was a lot faster than going through the file system, but file systems have gotten good enough to that making a swap file instead of a swap partition is like 99.99% as fast as a swap partition. So we only have to create a root partition and a boot partition. This is used by the kernel to store seldom used data and leave more memory available for active processes. Swap used to be a big deal until people realized how slow their computer was getting because they're swapping so much RAM to the swap partition, and yeah, it allowed you to run a whole bunch of programs at the same time, but everything got slower. So swap is kind of your enemy. If you see your system swapping in the old days, it was like if you could hear, you actually hear your hard drive just going crazy, because your hard drive light would just stay on all the time. You would know that your computer was swapping too much and was in a death spiral and was probably going to die anyway. So, and then it was reboot time. Let's see. The swap partition for an LFS system can be the same as the one used by the host system, in which case it is not necessary to create another one. Well, that's a good piece of info. I'm not sure that's true if you're using a swap file. Yeah, I'm pretty sure that's not true because you'd have to be going through another partition that another host is using to get to the swap file, and you wouldn't be able to do that unless you mounted it separately and was able to get at it. And I'm not sure it's a good idea. It probably would blow away any data that you had on your other system. All right, so in that case, having a swap partition instead of a file is a good thing. All right, this partitioning programs such as cfdisk or fdisk with a command line option, naming the hard disk on which the new partition will be created, for example, dev.sta for the primary disk drive. Creating a Linux native partition and swap partition if needed, refer to cfdisk and fdisk. All right. So other partition issues. Let's see. You want a root partition. That's where just about everything goes. Talked about the swap partition, and you need a grub BIOS partition. Nowadays, the partitioning program that or the partition table that all the cool kids use is the GUID partition table, GPT. It's a vast improvement over the master boot record. partition because it can address over 2 terabytes of information in the in any single partition. So that's what you want to have on your disk. And then there's a bunch of what they call convenience partitions, like /boot. We're going to do that. We'll probably do boot EFI. I don't know. I think I'll just do boot. And then home is where all your user data goes. You might ask why user data doesn't go in user, and it's just one of those things where that's the way they did it in the old days. And so I don't know why. Do you know why, Jace, why we use home for user data and user for system data or system programs?
I think that was a Linux thing because, I think Linux was the one that's either started or followed up with it because originally, in some some Unix-like operating systems, your home directory was in the /user directory.
Really?
Yeah, I think so. So yeah, or it was USER.
Yeah.
So, but then again, this is following the Linux standard-based file system standards. So, things change over time. There used to be the machine had only a couple partitions, and then like user and others were separate files that might be shared over the network, NFS or something like that.
Right. Yeah. Yeah, that's when space was a premium, and
yeah, exactly. And disks were expensive.
Yeah, absolutely. So it made sense to just compile a program one time, stored on a central computer that had /user, and then you would mount that over the network. So yep, and okay, so /opt. This is where optional software goes, like KDE or TextLive. So they can be installed without embedding the files in the user hierarchy. Yeah, 10 gigabytes is usually adequate. So in my career, /opt is where I would see programs like Confluence and Jira and Atlassian, the whole Atlassian tool suite. They would always be installed there. And I think I saw Oracle there also, but that's what I've seen. You can have a separate temp partition, but that's rare. But it's useful if you're configuring a thin client for like a browsable kiosk that you could install in a hotel or something. User source is where all the source files, so you could put the whole this is where you put the BLFS Beyond Linux from Scratch source files for compiling applications like TextLive or KDE. That's just the source code. That's not where the compiled binaries go. All right. Creating a file system on the partition. Okay, so once you create the files, once you create the partition, it's just a block device, which means the first byte is 0, and there's zeros all the way up until the last byte. So there's no file system on there at all, and you're not ready to put information there yet. And the way you do put information there is with a command like makefs. Well, that's the only command that you would use on a file system. If you wanted to install the ext4 file system, then you would do makefs.ext4, and that would know what to do. Or you could put the -t ext4 option between the makefs and the device, this /dev here. And this X would look something like SDA1, or which stands for Special Disk 1 or SCSI Disk 1. Back when SCSI was the faster disk drive and had its own naming system or naming convention. Regular hard disk was just HDA1 for hard disk A, partition 1. If you're using an existing swap partition, then you would there's no need to format it, and you can just initialize it with this command. So this would be make swap dev SDA1 or SDB1 or SDC3 for the third disk and the third partition. So yeah, and then YYY would just be the name of the partition. Okay, setting the $sign LFS environment variable and the user mask. Throughout the book, the environment variable LFS will be used several times. You should ensure that this variable is always defined throughout the LFS build process. It should be set to the name of the directory where you will be building your LFS system. We will use mount LFS as an example, but you may choose any directory name you want. If you are building LFS on a separate partition, this directory will be the mount point for the partition. Choose the directory location and set the variable with the following command. And there you go. Now, it kind of feels like we should be building stuff. And I'm not sure I can do that, but I can show you what I tried on Mac. I got close. So there is a new hypervisor for Macintosh, an open source hypervisor called Colima. And if I switch back to my list.
You say Colima?
Colima. This, here, let me make my.
Yeah, if you can enlarge that. So.
Yeah. No, all right.
And just so you know, the stream's been going for an hour 44. Oh, that's the stream. That's not the recording.
Yeah, I'm right. We're right about an hour.
Okay.
Maybe 50 minutes.
Yeah, now's the time to go rotate my car.
Were you able to do it?
Yeah, I was able to. I had to drive down the road though because there were cars all around me. So yeah.
Plus, okay, that's what it is. How's that? Can you see that?
Yeah, maybe one more.
One more, okay. That good?
There we go.
Okay. All right, so. I'm going to use the one that I know was working. So on Colima, it's a hypervisor that allows you to run, you know, virtual machines inside the Macintosh operating system. And I spent 5 days on this thing trying to figure out which was the magic. What were the magic
So again,
smells?
Started around 6:30. We should pause and restart the recording.
Okay, here we go.
yeah. Hey Ben.
Yeah.
Andrew suggested that maybe we stop the recording and restart for part 2 because Jitsy's gonna. Is it an hour that Jitsy?
Yeah,
Oh, I thought it was 2 hours. Oh, yeah, yes. So I'm gonna stop the stream and we'll pick up in part 2 here in just a minute.
5 seconds.
Okay.
If I could figure out how to do that. Stop.
Okay, welcome back to part 2 of Linux from scratch. And we're talking about how to get a hypervisor started on Mac OS. This is a M3 Mac running on Apple Silicon. And this is the way to start a virtual machine with a volume that is referencing BusyBox in my repos. Directory, which is also a separate volume. And it's case sensitive. I specifically built the repos volume to be case sensitive so it would be compatible with Linux, because I knew that would be a problem down the road if I didn't do that. And so I'm mounting 2 volumes here. I'm mounting there's 1 volume in the background, but I'm sourcing two directories so I can later mount them with another script. But this command right here establishes 4 CPUs and tells us that the mount is case sensitive. And so I'm going to go ahead and run that. It'll start Colima. It's using Docker for a runtime. It can use other runtimes like runc or and this is what killed me. Overlapping mounts not supported. And I had it working, and then all of a sudden this came up. So what I was doing was stopping Colima. That would like stop your virtual machine, but it could still be started and it would still have all the same settings. So if you blow all that away and start from scratch, then you would do this. And then it stops Colima, so it stops your virtual machine. It wasn't running in the first place anyway, so it didn't really matter. But then the Colima delete says, "Are you sure you want to delete Colima in all settings?" You say yes, and now you're done. Now you got a clean slate. So let's see if that fixes us. No, it didn't. Overlapping mouse not supported. If I type mount gives you all the devices on your system, just like Linux does, and tells you where they're mounted, just like Linux does. And so my repos is right here. And that is disk 3 slice 7. My repos. So that's one mount. And I think it's complaining that I'm trying to mount another thing over the top of that in the container. See, if I specify if I don't specify the volumes and I do clean with start, it still doesn't like it.
Well,
Yeah.
now the error message is relative paths not supported for mount case sensitive. So maybe if you do change your tilde to what is it slash user slash volumes.
You know what? I'm confusing myself here because there is another project called Linux from Scratch that is just a gist in GitHub, and that was a neat little project. I thought, oh, that's cool. I could do that, or a part of that, and use the VM in there to build Linux from scratch. But and I can show you the. I can show you the gist. Scratch. No, that's okay. I finally got the Linux from scratch on GitHub, but I'm looking for the gist. Well, I know it was in GitHub, so I can go here and just look for it. No, that's not it. Shoot. Should have never rebooted. Okay, so anyway, yeah, we went over to here as a general thing, but we shouldn't really be there yet. But we are looking to prepare the host system. Yeah, we haven't created the partition yet. There we go. So we need root. We need a root partition. That's maybe, and a BIOS partition for grub, and that's going to be the boot partition. Okay. So going back to Kalima. All right, here's where I was trying to. Yeah, okay, this is working. This is a virtual machine with 4 CPUs, mounting that repos volume that I have. That's doesn't care about capitalization, or does care about capitalization. Sorry. All right, so that just created the VM, and if I change to the right repos slash docker LFS, there's just two files in here. I'll just cat the Docker file. You can see. Wait, this is all that's in the Docker file. Using Debian as a base distribution, and is doing an apt-get update to update all the packages, make sure we're secure, and then that gist said you got to have all this stuff to do the building. There's that build essential package I mentioned earlier has all the development tools for Debian and Ubuntu distributions, and a few more ncurses is the semi-graphical interface that you get with running make menu config. XZUtils is a compression library. SSL is secure socket layer. EC, I forgot what that is.
Basic calculator.
Oh yeah. All right. Flex. Not sure what Flex is.
Lexical.
What does it do?
It's a lexical parser.
Oh, okay.
Yeah.
Live Elf Dev. Something about embedded linking format or something. Extended link format. Python is a compiler like GCC, and CPIO does a lot of copying of input and output. So to build all that, you run a big Docker command, and I can show it to you here. Oops, that was it. Try again. That's it. I think. Maybe not. Anyway, I already ran that command and built it, so I don't need to do it again. And then now I just have to run that shell. I should cat that first. All right, here's everything in the run that shell. It runs this big Docker command, interactive terminal, I guess, privileged with privilege access. It adds the capability of sysadmin, uses 4 CPUs, and targets the platform of Linux ARM64, and mounts these two as volumes. So that's what's in the run that shell. So to run it, we just go this, and the password, and boom. We are now in a container as the root user. The container's name is this long number right there. We don't really care about it. And the the test of whether it worked is the slash Linux directory should be populated because we told it to use everything in the Linux directory right here in repos and put it inside the container in a new path called slash Linux. Same with BusyBox. We told with this command, we told all the BusyBox code that's in repos BusyBox to mount it in slash BusyBox in this container down here, and we will know if it worked if this slash Linux directory has anything in it, and it does. Oh my goodness! All right, and slash BusyBox has a whole bunch of stuff in it too. All right, so. And so again, this is this other guy's Linux from scratch that he put in just in GitHub, and let's see, the way we tested it was the CD to the Linux, the slash Linux directory inside this container, and we would run a program using the make. We would run the make program with an option called defconfig that defines the configuration file called .config inside this directory that tells us how to build Linux. Okay, that worked, and we can see that that whole configuration was written to .config. Now let's see what all the options were for this. And to do that, you do make menu config. And this is an end cursors display that allows you to allows a little bit better way of choosing options than just putting -- option on the command line. So this is how you configure the kernel for just your machine or however you want to set it up. So there's a whole bunch of options. Some ones that are selected that have the asterisk in there. So we're automatically appending version information to the version string right here. We're doing System 5 interprogram communication. That's good. We're using POSIX message queues. That's good. We're using this enable process VM ready to write these sys calls. We're including auditing support. Probably wouldn't do that on a thin client. We got CPU isolation and we got kernel config support. So we're storing all that in the .config file. And now if I exit out of here, we can do platform selection. And these are all the CPUs that Linux supports. And that's not what you see on the screen is not all of them. So we go down. Yeah. So there's a whole bunch of chips. And that V plus right there. I think that's saying we got even more.
I was gonna say, is that next page?
Yeah, let me try.
Yeah.
Whole bunch of stuff. And in my case, I only want to compile for the ARM platform. So I'm going to unselect these by hitting the space bar, and the asterisk goes away. A whole bunch of chips we can turn off, and if we turn them off here, they don't get compiled into your kernel, and so your kernel becomes a lot smaller. You can put it on a small device.
Aren't you on Apple ARM?
I'm sorry?
Aren't you on Apple ARM?
I am, yeah.
Okay.
Yep. So that's this is where we can now save it.
Well, so the question was, he's asking about, it was up at the top there was Apple Silicon,
Oh,
but that's licensed by ARM. So would it be both be necessary?
Are you gonna run LCS on this machine? Or LSC?
LSC? What's LS?
LFS.
LFS? Thanks for
From
scratch. Oh yeah, yeah.
Yeah, you're installing it on the gaming rig, aren't you?
this is the alternative Linux from scratch I was trying to get working, but it's relevant for this presentation because it has a make menu config in it, which is what we're doing now, and we're about to. I just saved this, so I'm gonna go ahead and select exit. But I mean, to answer your question, I don't see any other. Oh,
That one. Yeah, it's not like it's alphabetical.
Perfect alphabetical order.
Yeah, yeah.
so sys. Okay, yeah, I will. Maybe that was my problem. So go ahead and save it again. It's going to save it as .fig.
Or we could just see what happens.
Yeah.
Do it live.
And so we exit, and then arrow over, and exit again, and now we can do the make -J $ processor. All right, so if you just type, then this container would try to make all this. It would try to compile all this code with one processor, but we specified 4 in the VM, so we can use 4. And the way you use 4 is by just doing this -J option, and using the $proc will return 4. So this is going to end up returning J4 to make, and we could just run it that way, or we could do $proc. But this is what it's going to do anyway. So, boom. This is how we wait. So, how long is this going to take? Man, we're at 7:57 already. Well, this is a good time to stop. Because this is going to go a long way. I mean, I doing this with 2 processors, it was taking like 90 minutes to compile this. Now, but when I added the 2 more processors, it dropped down. Oh, see that? Look at that. That's the problem. That xtmark.h, it cannot find that file because there's another file in that same directory XT mark that's capitalized. Hey, look. Oh, well, it bombed out. No wonder it quit. But yes. Now watch this. Watch this. This is all right. I'm finding in this directory type file. I'm looking for a file by the name of xt underscore mark .h. Fabulous typing skills. And it's not going to find it. If I change that to mark, capitalize, it does find it. Now, what happens if I copy that and do an ls?
Lowercase version. And rerun the make.
You saw it right there. It couldn't find the lowercase version, but if I do ls and boom and change it from cap, it's going to find that. It's definitely going to find this guy, right? There it is. But earlier, I had the wild idea. Well, let me just try the ls command and see if I can find it. And this is the wild thing about computers. When I ran this ls command, just like this, it found xt mark with the small letters like that. And that flipped my lid, and I said, well,
Let's just move it, right?
yeah.
And then rerun the
Symlink. Do a symlink.
Symlink or move it. Doesn't really matter.
Hard link.
Or it's really got to take 90 minutes to compile. Then we pick this up on.
Yeah.
Yeah,
Slash capital R and enter.
I swear it was there, and now I'm myself because it's not there anymore. So then I went to the GitHub. Say, okay, does this thing exist in the Linux kernel on GitHub? Because I can do a git pull right from the container. Watch this. Because I included that git program in that tools list. I said put it in that Docker file. I said put git in the container. There it is. There's git running from inside the container. It found some stuff. There's a new build. I mean a new release. I do this almost every day.
Would you be able to clone the repository from the official kernel repo?
Did
you? Because last I heard that the GitHub version of the kernel is like incredibly outdated and messed up.
Oh yeah, I never used that one.
Okay, good info. Okay, so here's all the changes in one day. One day.
AI, man.
They must have a build process that just like.
This is ridiculous. Even this is way more than I expected because usually.
Oh hey, look, that's one of my commits.
Look at all this stuff. I mean, I've never seen it this. Well, I did notice. I did poll yesterday, and there wasn't any updates. So this is likely a full weekend of updates plus yesterday, Monday, and today. So this is 4 days of commits. But holy cow! Everything in green was what was added, and then everything in red is what was deleted. So look at this. Holy. Okay, finally got to the top. Yep. So a whole bunch of stuff got added, and we can do it. LS, and it's still not there. But you can go to GitHub.
Well, based on what I'm just now reading, there's both XT Mark and XT Mark.
Right.
For net filter.
Right. And that's when I thought I got brilliant and said, "Oh, that's because the Apple file system isn't
Right.
sensitive, so it takes the first one, which is the uppercase mark." And I thought, well, I'm a genius, and I'm good to go. And then I reran it again, and then Mark disappeared. so I don't. Yeah.
So what you could do is go into your Linux menu config, go to the net filter, and just disable filter or the marking of net filter, and then not have to worry about it. I mean, because are you packets?
I don't even know what it does. Is that what it does?
Yeah, it marks. It uses net filter to mark packets to be for filtering, for quality of service.
Well, that's a good idea.
You need QoS?
No, no, not really.
Yeah, it's not a router, so get rid of it.
Does anything else use it though?
Well, no, that is another question.
Well, it's already past 8 o'clock, and this is turned from a
Yeah, you're right.
LFS thing to a is it Colima hypervisor talk.
Just on a whim.
Hold on, Ben.
Yeah.
Just on a whim, I'm wondering, what if you were to just MV the file to change it to lowercase just to see if it works? Like after you've pulled the repository, you just change the name of the file to being lowercase just to see if it compiles.
Did you hear that, Ben?
I'm thinking, they want me to change the name of XTMark to lowercase?
Lowercase mark.
Yeah, literally just change the file name. It completely different file, and that breaks some kind of include, but it would be really funny if it works.
Well, I know it isn't because I did do some research to find out what it's supposed to be, and the .h file is a header file, and it has some definitions. It has two function definitions in there that are different from what xtmark.c has in it. So the base file is mark.c. The file that's inheriting the other file is mark.c, xtmark.c, and it's inheriting xtmark.h, the header file. And there's also an xtmark.h that the capitalized one has some if and def compile directives that do a condition test to see if mark.h is even there, and if it's not there, then it allows the compilation to continue without crashing. I know the files are different. They do different things, and I fought it for 5 days. I couldn't get it going. I thought I had it one time, and then the fish slipped out of the boat.
They have an issue on GitHub for this.
GitHub has an issue, you say?
I'm looking for.
But it's apparently specific to Docker Ubuntu.
Docker Ubuntu. Okay.
No. No, so GitHub. There we go.
Processor target C select.
All right, here it is. Let's see.
Clone it from the repo line from git.org.
Yeah, here it is. It's just in 3 files. Here's the mark.c. See? The mark.c file is referencing xtmark.h, lowercase mark. But there's also in xtmark.h in that same directory that says if and def xtmark.h target, then go ahead and define it and include the xtmark.h, the little mark. And here's
Yeah.
the little.
Right?
So
I think it's getting overwritten on the whole.
That's wild.
Yeah, it could just be a weird get issue that like it's like I can't copy the same file.
Who would write their headers like that?
Well, but it's yeah.
I start another shell. That's serving right for having a long passphrase. All right, and I got, of course, I got two of them.
This just shows that naming things is hard.
Yes.
What do we do when the target is to Mark? Mark. All right. So what is it going to do? Mark. Let's call it Mark. So we got Mark the action and Mark the label.
And I know this file. I know this file system is case sensitive because I can touch XX and well, and capital X dot txt, and they both succeed. And if I do
So do an ls. Yep.
see, look at this. And there's the XX.
Yep.
I think I just solved why I only saw one, because I was looking here and I was looking for the capital XX right near it. And I was thinking, oh, it's not there.
Mac is
Wait. So you mounted this from a Macintosh file system, though, right?
Right, but I defined that Macintosh file system as case sensitive. I specifically
right.
did that.
Yeah, he did do that. There was a flag.
Somewhere along the way, Docker disagreed with you. And
So I think I was fooling myself and saying when I saw the
Machine was here.
when I saw, well, but the big question is, why am I getting something so different from what's in GitHub? That file has been in for like at least 9 years. It could be 19 years. Because if we go back to back to here, click on
All right.
it.
So I'm curious now. Exit from the, or not exit from the container, but on the main file system on your Macintosh's file system, is it two different files in that same directory? The mounted directory.
Good
It's repos.
question. All right, so let me change to Docker LFS. Oh no, not that one. All right, Linux.
Well, all right. So what is volumes repos?
Repos is where all my software repositories.
No, I'm sorry. Slash volumes slash repos.
Okay. That's all my software.
Okay.
And in here we have Linux
Okay.
right there, and we've got BusyBox right there.
Okay.
That's all source code. Source code.
So in the Linux directory there, let's see if different files.
Right. Okay, so
What was it?
find here, type F, name xt underscore mark h.
Change that to -I. And do your /vols/volumes/repos instead of dot.
You sure? That's going to search all these
Yep.
software issues.
Yep.
That's fast.
Going to take a while.
Okay. Then maybe just Linux. There's one.
There's capital mark.
And there's the other one in Tiger Beetle.
Yeah, I think I can't even remember what Tiger Beetle was. It's something I was interested in at one time, but obviously it's a Linux so.
You want to copy that file into the Linux directory?
So, yeah,
So you've only got the one file then.
You missing the file that's on the repo. You should be able to see it in
Yeah.
the diff with origin.
It seems like it's just some Docker Mac something.
Yeah.
here I'll do another git pull just to prove that I'm up to date because I did that same git inside the container over here.
Even if the file system is case sensitive.
Yeah.
So
Hmm.
maybe it's a bug in the Mac file system. I mean, I know Linus Torvalds hates the HFS Plus file system and on a Mac.
Yeah.
Do a git diff origin master -- name only. Git diff origin /master -- name only.
Like that?
No space between origin and master. Sorry, the first origin and the first master.
Oh, sorry. Or okay, I
And
got
then
you.
after that is after master is space -- name only.
Yeah.
All right.
Nothing.
What?
So
Clear
it's still applied. It's like the Mac Git binary.
Or it's still
cleared screen?
it's still thinking because usually you get a colon at the bottom.
Oh, there we go.
Yeah, there we go. Yep. So
Ah.
this is all the files you don't have.
Ah. And
Like
there's one.
uppercase versions or
Yep.
something, or slightly different case versions.
Hmm.
Wow.
I wonder if it's in your Git config. Because like I by default I turn on what is it? Unlike a lot of the case sensitive systems, there's like the line endings changes and stuff like that. There's like some pre-done ones for various operating systems. Like Windows will start you with the pull it down as though it's Windows and push it back up as though it's Unix.
Did I restart? How long has the stream got?
I'm blaming Git. Mac Git.
Okay.
Coming up 20 minutes.
So what did that just do?
You can hit Q to get out of this. This is just a diff of what is actually in the Git repo versus what's on your hard drive. Just proving that that is really up there, and it just won't pull it because it thinks that the other one is the correct one.
Oh. So I need to configure Git. to be case sensitive.
Maybe. The thing I saw on some random Git repo, not the kernel Git repo, that somebody was complaining about this problem, and that it was only happening with Docker running an Ubuntu image.
Wow.
Something.
Well, you, sir, are a $200 an hour consultant. I don't think I would ever got that. That is excellent.
It's Docker. Maybe Mac Docker is doing it.
Well,
Maybe it's the file system. It won't write it twice because it's already written
Yeah.
once, or it clobbers the second
yeah,
one.
I think Git is just saying
Because A
exactly
comes before
that.
some very capital
So-
FTP comes in after.
What's that?
Uppercase should
Yeah,
come in
yeah,
after lowercase, so it could be
Yeah, so it
overriding.
could override.
So if I copy this, I should be able to see the uppercase version of this. What? That's a lot.
Unmarked.
I forgot what it was. Oh. I gotta go back. I forgot what it was.
Mark.
Yeah, Mark. But I was checking another file to see if there
Oh.
was, see how
Oh, I'm
log is uppercase, and
Yeah.
all the uppercase files are like guardian header files that keep you from compiling stuff that you shouldn't. If another file isn't there, I think it was TCP mass. And all right, what was that? All right, I'm looking for. It was DSCP. That's one I wanted.
RAID EST was there. TCP.
Yep. There's capital DSCP.
Yep, sure enough. Okay, mystery solved. Man, that's great. Well, I know what I'm going to be doing in the next 5 days. Because that's not going to be the end of it. Oh man, all the stuff I had to fix with Kalima, and I like Kalima. It's just a tool, and you got to learn how to work with it. Kind of like find. Who would put the name that you want to find at the end of the string? I would say find this. But no, you got to put the directory first, and then put a name,
Yeah.
and then put a type. Yeah, that's not obvious to me. All right. Well, I've kept you all long enough, and we solved the problem. So let's call it a victory, and then we'll
We'll pick up where we left off next month.
next month. Sorry I kept you over, but
Thank you, Ben.
that was wonderful.
Appreciate that.
Yep.
Bill here, aren't we?
Well,
I wouldn't call this solved. Well, it will be once you grab all the files and manually write them, I guess.
now, do you want to pick up Ben next month, or do you want?
Yeah, I'll pick up next month if
Copy and paste
I mean, if you can't find anybody better. I mean, that would be literally anybody.
All right.
But yeah. And we're now at the point where we can start, creating partitions and stuff like
Right.
that. If you bring your laptops, we can attack it pretty well. And I'll have a month to work on the presentation. Okay. Thank you all.
All right. Thanks a lot. And we'll see y'all next month.
Yep.
Have a good night, everybody.
All right. You too. Bye, Jace.
Bye bye, Ben. Thanks.